We used to think of it as a mindless, oversized great white shark that ate everything in its path. But now scientists shattered that image of Megalodon to pieces. The question is, could it still be alive today? It appears it wasn't just a brute force monster, more like a highly efficient and adaptable predator. Basically, much smarter than we ever thought. New studies on Megalodon fossils and tooth distribution reveal that this apex predator didn't just wander the oceans randomly. It had a highly calculated global distribution. Megalodons actively mapped and followed the migration routes of ancient whales, treating the world's ocean like an interconnected highway system. It was more like a harvest for them rather than hunting. Fossil evidence also shows that Megalodon adapted its offensive strategy depending on what it was after in that exact moment. Targeting large whales was completely different than attacking smaller, more agile prey. Recent thermodynamic research suggests that the Megalodon was a highly energy-efficient creature, biologically engineered to maintain high cruising speeds across oceans without exhausting its energy reserves. Sounds like the ultimate machine, designed to survive, highly adaptable, and incredibly efficient. So is there any chance a small population survived to this day, deep in the unexplored ocean areas? As much as we do love the mystery, the harsh reality of the ocean says no. Why? We can assume that an apex predator this size would require a massive, constant food supply and pretty warm coastal waters to raise its young. Nowadays, it won't be possible to hide an animal of that scale. Someone would definitely notice it. Who or what defeated the Megalodon? Not a bigger predator or lack of intelligence, but our planet itself. A series of massive Earth changes and severe climate shifts happening around 3.6 million years ago completely redrew the map. The oceans became cooler and turned into polar ice in some places. Plenty of warm and shallow coastal waters just vanished, causing the Megalodons being unable to raise their young. At the same time, what was their primary prey? Whales, adapted well to freezing temperatures and moved to icy waters. Megalodons simply couldn't follow the food. In the last chapter of their story, it appears that massive size became a fatal disadvantage. The global food supply chain collapsed, the Megalodons starved, and finally ended as an ocean mythical creature today. For years, we've thought the Megalodon was just a big shark, which is scary enough. After all, it could have eaten a creature the size of a whale in just 5 bites. Estimates indicate that the largest shark that ever lived had been around 59 feet long, which is a reasonable size and explains a lot. But the scientific community was wrong. Very wrong. Now, scientists have proven that megalodons could grow up to 80 feet long, which is the same as a 6-story building. The creature would have certainly been dozens of times bigger than you if you had seen it underwater. These giants ruled the ancient oceans between about 20 million and 3 million years ago. And even though it was a long time ago, they've left a lasting impression, becoming the protagonists of many movies. And scientists continue to search for answers about their life. Thanks to this, we still occasionally find their fossils. But the thing is, no one has ever found a complete skeleton. All we have are scattered vertebrae, a few scales, and, of course, those massive, razor-sharp teeth. The most complete piece we know of is a 36-foot section of a megalodon's spine. It was once part of the trunk of the animal's body. So, to assess just how big the megalodon was, experts compared its fossils to more than 150 species of sharks, both those that are alive and those that have gone extinct, to get the most realistic result possible. If the megalodon had had the proportions of a regular shark, it would have had a 6-foot head and a 12-foot tail. It would have also stretched 54 feet from nose to fin. But these measurements are way off the mark. The largest megalodon vertebra ever found is 9 inches in diameter, which makes it 3 inches larger than the largest vertebra of a typical shark. And if we follow these proportions, that Megalodon was a whopping 80 feet long. To better understand how giant this is, just think of 2 school buses lined up end to end. For a long time, it was very common to think that the Megalodon was just a giant great white shark. And it makes sense, right? I mean, both would have had large, terrifying, serrated teeth. But that was another completely wrong idea. Now, we know that Megalodons were actually much more slender and aerodynamic than the modern great white shark. Their body shape was built to cut through the water with much less resistance, minimizing the effects of gravity in the sea, letting them glide effortlessly through the ocean. Now, if Megalodon wasn't just another great white shark, what other animal of the same species was it most similar to? Surprise! In fact, it had more in common with the modern lemon shark. This species has robust and powerful bodies, 2 large dorsal fins, and blunt snouts, which makes them really fast and agile hunters, like prehistoric predators. In other words, while thinking about the Megalodon, you can imagine a giant, turbocharged lemon shark. This is the most modern comparison of the Megalodon with another animal, unless scientists find a complete skeleton of the ancient shark. But it's not common to find complete shark skeletons. They're rare because they're actually made not of bone but of soft, coated cartilage, like the stuff in human noses and ears. Their teeth are the boniest part of their bodies, and it's the reason why we've found so many of them. Yet, a complete skeleton is like scattered puzzle pieces to us. There's no solid bone to hold these pieces together, so the whole thing is very vulnerable to falling apart. Still, it's actually possible for an entire shark skeleton to survive. In these cases, very specific natural phenomena have to come into play. The skeleton needs to get buried super fast in mud or sediment, free of any kind of scavengers and away from ocean currents. Otherwise, it simply disintegrates before it can fossilize. Interestingly, although the sea is the home of these animals, it is possible to find their skeletons on land too. Millions of years ago, a big portion of today's dry land was submerged, teeming with marine life. Then, in certain places, sedimentary minerals and specific biological conditions of the seabed allowed the fossilization of sharks in marine rocks. Today, those are desert rocks that ensure the preservation of shark fossils. But in any case, searching for a shark tooth in a desert is like looking for a needle in a haystack. But finding an entire fossilized skeleton embedded in a rock is like hitting the jackpot. Another unexpected discovery is that these prehistoric sharks were not born small and cute like regular baby sharks. A newborn Megalodon could reach almost 13 feet in length. That's more than twice the height of the average human. Imagine a shark the size of a boat from the moment it's born. Now, although we don't have all the information about the giant of the seas, it's a fact that it's one of the most famous animals in pop culture worldwide. Not only has it inspired several movies, but some people also insist that the Megalodon is still alive. Scientists say it's not. The Megalodon didn't survive the test of time, and it would be impossible for such a giant creature to dwell in the seas without us noticing it. First, it was a super predator. It hunted whales, dolphins, and other large marine animals. If the Meg was still around, its presence would completely change the balance in the oceans. It would have huge impacts on marine ecosystems, regulating populations and influencing the size and behavior of the ancient shark's prey. A good example is whales. They wouldn't have grown so big if the Meg still hunted in the oceans. This only happened because there was no super predator in the way. If the giant shark was still in our oceans, species like the blue whale would be tiny, as they would need to develop and adapt to be able to escape constant attacks. The lives of the workers of the sea would also be completely different. Fishers would have to avoid certain areas, ships would change routes, and even maritime tourism would be risky. Going for a swim and coming across a shark over 65 feet long? Not worth the risk. Plus, if the Megalodon was still out there, we would have some proof. Commercial fishing catches millions of sharks every year, and a monster of this size would not go unnoticed. Not to mention that with all of today's technology such as drones, satellites, and submarines at our disposal, someone would have already recorded an encounter with this living legend. By the way, most sharks, like most fish, are cold-blooded. But the reality for Megalodon was different. This giant was able to keep its body warmer than the surrounding ocean. This gave it an advantage over other sea creatures, allowing it to remain fast and active even in colder waters. It was a survival advantage that other animals of its kind did not acquire during their evolution. One of the most famous theories is that the Meg lives in the Mariana Trench, but scientists are sure that it doesn't make any sense. This region is poor in food and has many tiny creatures, which would not be nearly enough to sustain a large predator. In addition, there's a lot of research studying countless sharks that live in the ocean depths, and none of them come close to the size of the Megalodon. So, does the Megalodon still exist? Definitely not, but that doesn't mean it isn't any less mysterious and fascinating. It was the largest fish our Earth had ever seen, and its bite was strong enough to crush a car. The largest of its teeth found was the length of a remote control. It consumed about 2,500 pounds of food a day. That's like 3,300 cans of tuna for you. The earliest Megalodon fossils are from about 20 million years ago, but you won't see its skeleton, and that's because the mighty Meg had no bones. A skeleton made from bones gives most animals their body shape and strength. Sharks, though, come from the same subclass as rays, skates, and sawfish and have cartilage instead of bones. Cartilage is a tissue that is softer and more flexible than bones, but it's still tough enough to shape the body and protect the internal organs. Some areas are more flexible, since cartilage is weaker, and some, like the shark's head, are much tougher thanks to calcified cartilage. Their snouts, though, are made of really soft and flexible cartilage to work like a bumper in case of a collision with some dangers. Who knows if they'd be able to do all this with a heavy skeleton? Plus, cartilage makes their jaws more flexible, and they can open their mouths much wider than they would with a jaw made of bone. Our hero, Meg, was no exception, and it had the strongest bite of all living creatures, which was also made possible by a skeleton made of cartilage. Sharks take full advantage of their cartilage. It helps them swim and turn fast while hunting. One drawback of this type of skeleton is that it was really tricky for scientists to establish the shape and size of Meg. Normally, they would do it using fossilized bone skeletons or their parts. With Meg, they had to guess based on the teeth they found and comparisons with living relatives. A more recent 3D computer model was based partially on scans of a preserved spine discovered in the 1860s. The model showed that Meg was bigger, faster, and even hungrier than scientists had previously thought. Looks like an average Megalodon was 52 feet long. That's slightly bigger than the height of the Hollywood sign and weighed 10 times as heavy as an elephant. There were also much bigger creatures. Scientists still aren't sure how the Megalodon got this size. The fact that there were bigger and smaller Megs probably has to do with a little something called Bergmann's rule. It says that the temperature of the surrounding environment affects the animal's body size because they either need to conserve or shed heat. The Megalodons that reached cooler waters probably needed more body weight to make sure they survived in low temperatures. Those living in warmer waters had to be smaller to avoid burning up. If the researchers were correct in their calculations, it also means that Meg reached a cruising speed of over 3 miles per hour, which is much faster than other sharks. The still-living great white shark can cover a distance of nearly 7,000 miles without stopping, which is 9/10 as long as the diameter of Earth. It looks like the Megalodon could have gone much further. Megalodons managed to survive on our planet for nearly 70 times longer than humans have. They were roaming the oceans for around 20 million years, and you could see them pretty much anywhere except near the poles. Scientists discovered the most northern fossils off the coast of Denmark and the most southern in New Zealand. The reason why there were no Megalodon teeth found in Antarctica is most likely that these adapted to only warm tropical and subtropical waters. The younger ones like to keep to the shores, while full-grown adults preferred coastal areas, but they could easily move into the open ocean as well. When our planet went through a period of global cooling and drying, and the seas began to freeze around 3.6 million years ago, there was less and less room for Meg to thrive. Much of their prey, like smaller whales, seals, and sea turtles, disappeared or relocated to waters that were too cold for our hero. And at the same time, the number of its natural competitors, like smaller predatory sharks, like the great white shark, and whales, increased. This shifting food chain dynamics could have been even more dangerous for the Meg than the cold ocean water. You're used to seeing them on the big screen as heartless monsters, but these huge sharks were actually loving and caring family guys. Scientists discovered several Megalodon nursery areas in Florida, Maryland, Panama, and off the coast of Spain. It looks like they gave birth to their young in shallow water environments. Then, little Megs would stay there with adults protecting and raising them until they were ready to fight off predators. The mighty Meg had 276 teeth in 5 rows in its mouth. Similar to other sharks, it was fast in replacing its worn-out or lost teeth. With 4 or 5 rows of teeth in its mouth, it basically acted like a conveyor belt, able to grow back damaged or missing teeth. This means that an adult Megalodon probably would have grown several thousand teeth throughout its lifetime. Although the great white shark is often mentioned as Meg's closest relative, they'd hardly be distant cousins. The ancestors of today's great white existed at the same time as the Meg, but they weren't best friends and even rivaled each other. The great white shark wouldn't win in a head-to-head fight with a Meg, but it was a better hunter using its smaller size and agility to snap up the giant's prey quickly. This only left the bigger fish and whales for the Meg, but its food supplies began to run out as the whales swam to the cooler new seas. Rather than a great white, the Megalodon is more like a modern bull shark. It had a short snout, a flat lower jaw, and huge pectoral fins to support its massive weight and size. We also speak of Meg as an extinct giant, but can we be 100% sure it isn't hiding somewhere as we speak? After all, we've only explored 5% of our oceans altogether. The Mariana Trench is the deepest oceanic trench on Earth, and you could dip the whole of Mount Everest in its deepest part, and over a mile of it would still be above the surface. If a Megalodon or 2 needed a place to hide, that would be the perfect spot. It wouldn't be the coziest place to live, though, with its cold water and total darkness. Plus, the pressure there is 1,000 times stronger than at sea level. So, if a Meg really were hiding down there, it would have serious issues with its teeth, because calcium would dissolve under that pressure. To survive here, it would also need to learn to navigate in complete darkness. That means it would have either become bioluminescent or evolve to grow massive eyes like the giant squid. If the Meg were still around and true to its dietary choices, it would have to eat smaller fish, and that would be a problem for us humans. Especially those of us who love fish, that is. And the ocean isn't cooling down these days. The Megalodon would love its temperature and would thrive and reproduce faster than ever. Those giants would create some massive problems for cargo ships and cruising vessels. In case you're now scared at the thought of meeting a Megalodon, relax. Most scientists don't think it's possible because of our hero's size. Most foods that Megalodons like to eat live in shallow ocean areas and not in the deep, deep sea. Meg would need to come up for dinner every now and then, and it's kinda hard to miss a creature this big. They're both giant prehistoric creatures to us, but the megalodons and the dinosaurs never actually coexisted. The dinosaurs probably died out about 66 million years ago. Megalodons seem to have appeared a bit later.